March 1918, we're in the port city of Saint-Nazaire, France, where a vital railroad link runs inland to Paris. Here, the United States military has set up several railway battalions. At home, President Wilson has seized control of the railway systems, which have fallen into disarray since the boom times of profit and achievement at the turn of the 20th century. He formed the United States Railway Administration, which sets new standards for design and production. These standards will lead to unprecedented levels of efficiency and production, both in military factories and in military railway battalions abroad. In the battlefields of Europe, this conflict has become a war of attrition. Railroads can bring reinforcements to the front lines much faster than infantry troops can advance across fields of trenches, barbed wire, and mud. In this war, once again, the goal of the armies will be to take advantage of the railroad speed in mobilizing troops. The Military Railway Service, a branch of the United States Army Corps of Engineers, has been sent to France. There are 20 military railway operating regiments, 6 maintenance of way regiments, 8 car regiments, and 12 locomotive shop regiments here to construct, repair, and operate the railroads. The cars being assembled here are manufactured by the Standard Steel Car Company. Arriving in crates containing a jigsaw puzzle of parts, the assembled cars will carry trucks and tanks, provide housing for the men who work with the field artillery, carry ammunition to the front, and contain portable kitchens and field hospitals. In cars such as these, nearly 4.5 million gross tons of supplies will be transported to the fighting front, reaching a peak in October 1918 of over 8,000 tons per day. These are steel ammunition cars, which will be used to haul shells and powder bags for a variety of heavy railway artillery, including the United States Navy's 14-inch 50 caliber railway gun. Four-wheel trucks are placed on the rails and the cars are built directly on top of them. This is done for efficiency because when the last rivet is in place, the cars are already on the track and ready to roll. Steel reinforced sides and roof supports are mounted on the car's frame and riveted into place. Some of these ammunition cars will accompany the Navy's 14-inch railway guns. Between the first shot fired on September 6th through the armistice on November 11th, the Navy's heavy railway artillery will fire 782 rounds of 1,400-pound shells at a distance of 17 to 22 miles. Locomotives built to the American standard will supplement the narrow gauge lines in use for frontline traffic in France. The locomotives are also shipped here in pieces and assembled by American soldiers. Baldwin Locomotive Works of Philadelphia, Pennsylvania is devoting its entire manufacturing capacity to the construction of railroad equipment for the war. It builds the Iron Warrior, the standard gauge steam locomotive, which will be used for high-speed, long-distance, large-capacity transport. Baldwin will also construct narrow-gauge locomotives and rolling stock, as well as manufacture a total of 6.5 million artillery shells. The name Baldwin has been associated with railroads in combat since the Civil War, when the company introduced a standardized system of interchangeable parts. Baldwin began to develop standardized gauges during the war between the states and had perfected a set of master gauges by the 1890s. During World War I, all parts with machine surfaces are accurately fitted to these master gauges. The Baldwin locomotives assembled here in Saint-Nazaire are consolidation-type engines with a 280 wheel configuration, 21 by 28-inch cylinders, and 56-inch driving wheels. The engine has 35,600 pounds of tractive effort and weighs in at 166,400 pounds. That's 83.2 tons, more than 2.5 times the weight of Baldwin's Civil War locomotives. Here the locomotive's frame is lowered onto its wheels, which are already in place on their axles. The large wheel size indicates that the locomotive is intended for high-speed running over long distances. These men are at work on the cylinders and valve gears. Steam entering the cylinder forces the piston backwards, moving the drive shaft and causing the wheels to turn. At the heart of the Baldwin steam locomotive is its boiler. The boiler barrels are made up of circular steel rings. The semicircular section attaches to the firebox. Boiler tubes run through the boiler from the firebox to the smoke box. These tubes carry the heat of the fire through the water in the boiler and then exhaust the smoke out through the stack. The boiler is placed on its frame. Careful placement is essential, both for proper distribution of weight and for a correct alignment of engine components, such as the firebox's damper doors. The smoke box is at the front end of the locomotive. The smoke box has a hinged door, which is airtight when secured. Controlled airflow comes through the blast pipe of the smoke box, increasing the heat of the fire and expelling the combustion gases. The locomotives are now in the final stages of assembly. From a jumble of parts that arrived in crates at the docks of Saint-Nazaire, the Baldwin locomotive is ready to roll down the road to war. Each completed locomotive is the result of the dedication and ceaseless efforts of dozens of soldier railroaders. The premier accomplishment of the railroads during World War I will be the standardization of equipment and the acceleration of production. By manufacturing these interchangeable parts, the cost of production will decrease substantially, and the speed of repair and assembly will increase dramatically. The first engine built by Baldwin for use in Europe takes 20 days to complete. But by the end of the war, at the height of their capacity, Baldwin will build 300 war locomotives a month.